So our last section in chapter 3 is optimization problems. So when I say optimization, what do you think we'll be doing?
I'd say solving min and maximum problems.
Yes, and how did we do that?
By
Finding what?
doing stuff.
The zeros at the first derivative? Yeah. The critical numbers. Okay, so that's what we're going to be doing. A little bit more involved than that, but essentially that's what we will be doing. So a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum volume? So we have two equations going on in there. What are they?
Volume and surface area.
Surface area and volume. Yes. So I always like to sketch myself a little picture so my brain can keep track of what it's doing. It is an open box with a square base. It didn't say anything about it being a square, like a cube, did it? No. So I'd have X, and can we just call the height? Okay. So what do I know?
You know that the surface area
should be 108.
Okay, so the surface area would be 108 equals, well, what would my surface area consist of? The areas of all the sides, yes? Okay, so what is the area of the base?
X squared.
X squared. Plus, now all the sides are going to be the same area, yes?
So 4xh.
4xh. Okay, so that's my surface area. And my volume, because it says maximum volume, will be what times what? Times what?
X squared.
It'd be x squared h. My problem here is, hopefully you noticed it, is I have how many variables? 2. I have 2 unknowns, don't I? And I probably want only what when I'm working with it? 1. So since I'm looking for the maximum volume, I'm going to differentiate the volume function. Correct? Whatever you're looking for the maximum of, that is what you're going to find the derivative of. So can I solve this equation for x or h and plug it back into this equation, the other equation? And then I would be in how many variables? 1. Okay, so let's decide which variable we're going to solve for. I'm going to say h.
I would say H.
Why would we say h?
So we don't have to have square roots.
Yeah, and then we have, over here we have x squared and x. Could that be pretty gross? Yes. Okay, so if I were to solve for h, I would subtract x squared and divide by 4x. So h equals 108 minus x squared over 4x. Now I'm going to substitute this back in for that h. So I have x squared, 108 minus x squared over 4x. Now, I personally do not want to do a quotient product. Do you? No. Can I distribute the x squared in?
Yeah.
Okay. Well, before I do that, I'm going to reduce out an x. Okay. And this 4 goes under both the 108 and the x squared. So Does 4 go into 108?
Yeah.
Yes.
7 times.
27 times. So we're going to have 27x.
Uh-huh.
Okay. And then negative 1/4 x cubed. Okay. So now I'm down to one variable. Am I good then? Yeah. So we're going to now take the derivative. So dv over dx. So what variable are we differentiating?
Okay.
X, because it's in the denominator, right?
Mm-hmm.
We've got lots of review going on, don't we? So what's your derivative going to be?
27 minus 3 over 4x squared.
Did you say minus?
Yeah.
Okay.
Thought I said something.
That didn't sound like what you were saying. Is that what you meant?
Yeah.
Okay.
What do you think I said?
I don't know. I was like, that is not what it sounded. Okay, so now that is the derivative. So I need to set my derivative equal to 0. So, well, if I set it equal to 0, that makes the 3/4 positive, doesn't it? That was easy. Multiply by the reciprocal, so 4/3.
I dislike how you did that.
Why?
Drawing the equal sign over the negative.
I do that all the time.
Never seen you do that before.
On my work, I do it all the time. Sorry. Why wouldn't I do it that way?
I don't know.
No, I don't do it typically in classes because I don't want to mess anybody up. Did that mess anybody up in the room?
No.
Okay, so then what's wrong with it?
What's that mean?
Okay, so 9, so 36. So x equals...
Plus or minus 6.
Okay, so are both of those good answers?
No.
No.
Because distance can't be negative.
Distance can't be negative. So x is going to be 6. So now what?
Now we need to find h.
You need to find h. So 108 minus 36 over 24.
Yeah.
So 272 over 24,
We.
which I think is 3.
Yeah.
So my dimensions are going to be 6 by 6 by 3. Because it says, what is the dimensions?
You know, since it's an open box, wouldn't the inside also be surface area?
No,
Okay.
because you don't count an area twice. Nope. So what we did, and if you want to write it down, it is on page 220, because I'm not going to wait all day. So identify all given quantities, all quantities to be determined. If possible, sketch a picture. Okay. We sketched a picture. We kind of identified them. We didn't like state it. Write the primary equation and the secondary equation. So the primary equation is for the quantity that the maximum or minimum you're looking for, and the secondary is what you're going to use to substitute in. Okay, I'm not going to make you identify a primary and a secondary. The primary, though, is the one you're trying to maximize, because that is the one you're going to be taking the derivative of.
So like in the last one, that would have been the volume.
Right, the volume was your primary, the surface area was your secondary. Determine the feasibility of the primary equation, that is, determine the values of which stated problem makes sense. So the plus or minus 6, we got rid of the negative 6. And then determine the max or minimum values by the calculus techniques discussed in section 3 through 4, or 1 through 4. So we did all those things, right? We found the two equations. We wrote in one variable because you cannot, well, I don't want to do implicit differentiation on this, do you?
No.
No.
Maybe. I don't know.
We go back to the rate of change problems. Do you want to do that? Probably not. Okay, one more example. Do you need me to go back? Kale,
No, I got it.
are you sure?
Yeah.
Sorry, I hit that and I wasn't. That's really small. Okay, a rectangular page is to contain 24 square inches of print. The margins at the top and the bottom of the page are 1.5. The margins at the left and the right are to be 1. It says see the figure, but we're going to draw the
Did you
picture.
know the problem with like the parabola and the dot? Because I remember the answer to that one. It needs to be done quick. Never mind.
Okay. This is our last example.
Okay.
Okay. So I know left and right. So if I call this is X, yes? But then there's 1 inch and 1 inch.
Yes.
Okay. And if we call this, well, we called that one X, I guess we're going to call this one Y.
Great idea.
We have 1.5
And 1.5.
and 1.5. And our print is going to be, our print's going to be in here, yes? I'd have to make it realistic. This is how I know everyone knows what they're doing when I get amazing pictures. Those lines are pretty spaced. Good.
We'll just do an art project for each project.
Yeah, that's when I know.
Finale.
That's when I know that no one knows what's going on, when I have amazing pictures. Okay, so I need to figure out what's going on. What should the dimensions of the page be so that the least amount of paper is used? So I would assume we're talking area, yes?
Yeah. Yes.
Okay, so, well, it says 24 square inches of print.
Yes.
So that would be 24 equals X times Y?
Yeah.
Because that would be without the margins.
Yes.
So the area of the paper then would be if you look at their picture in the book, they put their X and Y. They put their Y on the top and their X. They put their Y horizontal and their X vertical, and I cannot do that.
Interesting.
I'll bet it would be like the X plus the inches on the side, right?
Right, so X plus 2.
Times Y plus 2.
Mm-hmm. So if you go look at the example in the book, I just know that our picture was drawn differently. Okay, so we got X and Y. Obviously, this is what we are going to be differentiating, yes? Do you want to solve for X or Y?
X.
X. So if you solve for X, we'll leave them Y. That's what you want to do? So X equals 24 over Y. So we need to make this X what? 24 over Y. Now, I don't particularly want to do a product rule, do you? No. Now, if it was cubed or something, we'd have to. We don't have to. We can distribute this. No one is telling me anymore that I have to be able to do the product, the quotient, anything anymore. So I can do whatever I want. So let's FOIL it. So 24 over Y times Y would be 24 plus 72 over Y plus 2Y plus 6. So area equals 30 plus 2Y plus 72 over Y. I just think that fraction needs to be at the back, don't you? Now what's my next step?
Differentiate.
Differentiate. So d of a over d of x. Oh, not d of x. D of... Kale, that was so weird that you picked y.
She scares me when she's on a video.
Okay, so my derivative?
0 plus 2.
Actually, the whole reason I did that was so it said daddy if you spell it out.
Oh, gosh. Oh, can I write up here? Can I write this 72 times y to the negative 1?
Well, that'll be handy for differentiating.
I mean, I just see it that way, but... Okay, so then I might get, what, 2 minus 72 over y squared?
Yeah.
So I now have to set this equal to 0. And I'm going to bother Kale again because I'm going to add over 72 over y squared. So I'm going to change my negative to a
Equal sign.
equal.
See, at least that one you just straight across from the other one. The other one, you had equal sign, negative, equal sign. So they were like stepped like that.
Oh,
But
So-
the main thing was that you just did it.
okay. And then so I get 2y squared equals 72. So y squared equals 36.
crazy.
That is weird. So y equals plus or minus 6, but it is really only positive 6.
No,
So if y is 6, x is 24 over 6, so it is 4. Now those aren't the dimensions of the paper though.
no, the dimensions of the paper are
Just have to
6
add
by
the
9.
margins. Right?
Yep, so we have to add the margin to the x, so 4 plus 2. So I'm going to do this because Natalie isn't here.
She'd probably get very confused.
By 6 plus 3. So my dimensions are 6 inches by 9 inches.
Well, that's not what size paper is.
What's a book?
What?
It's a book. Books are all different sizes.
It doesn't say anything about it being a book.
Well, it's print on it.
It says a rectangular page is to contain 24 square inches.
I would assume it's a page of a book,
Okay.
especially 6 by 9. It's a large book, but it's still a book.
You should go down to the library and
Find a
6 by
book
9.
and find a 6 by
Yeah.
9.
You should do that. That is valuable use of time.
Okay. Yeah, because